Now, after the nuclear tests had finished, there was an attempt to decontaminate Maralinga. Now, the extent of the fallout from Maralinga is controversial. There are all the stories of this mist that spread around and hurt people. Many of the scientists think may or may not be true. But however, today, the radioactivity from the bomb explosions has mostly decayed away. Most of the isotopes produced by atomic weapons explosions have very short half-lives, and even within days or weeks, radiation had dropped drastically, and now, decades later, that's the direct effect of the atomic bombs is not a problem. What is a problem, however, is that after they finished the nuclear tests themselves of bombs, there were a number of other tests. They were interested in what would happen if a bomb exploded accidentally, or if the bomb exploded near another bomb. And so there were lots of small explosions where chemical explosives were used to blow up bits of plutonium to see what happened. And these are much worse because they scattered plutonium, which has a much longer half-life, over the desert. There was an initial clean-up done by the British, which more or less consisted of taking the most radioactive bits of metal and burying them in shallow pits. Wasn't very comprehensive. But later years, it became clear that the initial clean-up had done a very bad job. Once again, a case of people either being sloppy or lying. I guess the people doing it thought, this is uninhabited, nobody lives here, why do I bother putting too much effort and money into turning it over? No one's ever going to come here, it is very remote. But again, that's not the point of view of the indigenous people. The main problem was that chunks of plutonium, not from these atom bomb tests, but from the smaller tests later, were scattered all over the place. Here, for example, is a chunk of uranium just left lying on the surface. So another cleanup was done. Mapping was done. Here's a vehicle with 4 radiation detectors that would drive backwards and forwards and backwards and forwards and backwards and forwards and try and map everything. And you can see the map of the radioactivity. And what you can see is there are particular channels or V-shaped channels of radioactivity, and there were basically experiments done over here where radioactive material, often involving plutonium, was fired out in these directions. And it's these chunks of plutonium that cause the problem. So there's a major one here, minor ones in some other directions, and some other little patches around, and plus the main radiation over here. So what was to be done about this? There was a lot of consultation with the indigenous communities, and they basically said they wanted their land back. They felt that they had suffered very badly from being taken away from their traditional land, and they wanted to wander across it, and they probably weren't going to live there, but they would maybe set up temporary camps and move around. So what was done was the 2 square kilometres which were most contaminated, all the topsoil was dug up and buried much deeper underground in huge pits. The pits left over from the first British cleanup with the most radioactive material were buried deeper, and what was called in situ vitrification was used, which is where electric currents are passed underground to melt the material and turn them into a glass. The idea of this is it's to stop plants, for example, sending roots down and sucking up the radioactive material or water seeping through it. If it's in the form of glass, it's just going to stay there. They could not take all this area. Bear in mind the scale here, we're talking about 5 kilometres, 10 kilometres, it's a huge amount of area, and they felt the environmental damage of digging up all the soil and trying to bury it would do more harm than good. But the most radioactive areas down around here were dug up, 2 square kilometres, and buried. And so now the entire zone is considered okay for moving across and hunting on. So the quote from the cleanup people, again some would not believe this, is it's now impossible for casual visitors making intermittent forays to the area, for example tourists, geological prospectors and surveyors, who do not engage in abnormal dust raising or large-scale soil disturbance activities, to receive a committed effective dose by inhalation of anything approaching 1 millisieverts. Why they're talking about inhalation is because most of the remaining radioactivity is from plutonium, and touching plutonium has no effect because it produces alpha particles that cannot penetrate the skin. The real risk is that this plutonium dust gets stirred up in the air, it gets breathed in, and then it can give you a lot of trouble. So the most dangerous zone was cleaned up. The smaller 100 square kilometre non-residential zone is thought to be fine for most purposes but considered dangerous for permanent camp with kids playing in the dust. It's fine to go there and camp for a week or a month, but the idea is that they looked at the worst case scenario. They talked to the indigenous people and said, what are you going to do in this land that might raise a lot of the dust up? And the basic trouble was if they decided to camp somewhere permanently and the kids were playing in the dust. That was considered to be the worst case scenario. Just walking over it and hunting, not a problem, but that was the big problem. And so the basic idea is that now, if you're in this region and you were camping permanently for a full year in this region and doing things that kicked up the dust, like kids playing in the dust, even then the radiation dose was originally intended to be less than 5 millisieverts, but actually is going to be less than 3.7 millisieverts per year. Now compare that to the average Australian radiation dose of 1.8 millisieverts. It's a bit higher, but it's certainly lower than natural radiation in many parts of the world. So, again, you could have done more. This was $100 million. You've got to look at the cost-benefit here. $100 million spent on malaria nets in Africa would save thousands of lives. Here, in the worst-case scenario, it would mean that there's not much risk of a very small dose of radiation, it therefore allows the indigenous people to move back into the land. So this was considered, rightly or wrongly, to be a good compromise. You could have spent $1 billion and cleaned up more area and maybe reduced the area where it's 3.7 to maybe 2 or 1.5. Was that worth a few $100 million more, plus the environmental damage of digging up all the soil? Interesting question.